energy. Ionization energy or ionization enthalpy కూడా అంటారు. What is ionization enthalpy? మామూలుగా మనకి the minimum amount of energy is required to removal of outermost electron in isolated gaseous atom. The minimum amount of energy is required to removal of outermost shell. Then outermost shell is valence shell. Outermost shell is isolated gaseous atom. Then it is called ionization energy. Then ionization energy, it does not contain solids and liquids. That is only applicable to gaseous atoms. Then gaseous atoms is easily removed to outermost electrons. Outermost electrons, for example, aluminium atomic number 13, electron configuration 1s2, 2s2, 2p6, 3s1, 3s2, 3p1. Is the outermost electron 3p1. In the mostly removal of outermost electron in gaseous atom in ground state. Two more important points in ionization energy, removal of electron. First one is the atom is gaseous atom. In gaseous atom state is ground state. In the ground state, aluminium electron configuration is 1s2, 2s2, 3p, 2p6, 3s2, 3p1. Is the ground state, outermost electron is removed. Outermost electron is removed in gaseous atoms. For example, outermost electron 3p1 can remove the one electron, that is Al gives rise to Al plus one electron is removed. This is called first ionization energy, IU1. First ionization energy. Then another second electron remove. Al plus another second electron is removed. Al plus 2. That is second ionization energy. Then another electron Al plus 2. Al plus 3. Third ionization energy. This one electron, in outermost 3 electrons only can separate the one electron there. It is not formed directly Al plus 3. It is only first outermost shell electron is removed to give Al plus ion. Then next second outermost electron is removed to form Al plus 2. Then another one, outermost electron is removed to form Al plus 3. That is IE1, IE2 and IE3. First ionization energy and second ionization energy, third ionization energy. The minimum amount of energy is required to remove of one electron in gaseous isolated atom to form unique positive ion. This for example, M is gaseous state. It is M is element. Then one electron is lost to form M plus ion. This is first ionization energy. In the first ionization energy, this is the unipositive ion. Then unipositive ion, to remove one electron to form a bimolecular ion. This is second ionization energy. Then first ionization and second ionization energy, third ionization energy, in relationship between the IE3 is greater than IE2 is greater than IE1. For example, Al gives rise to Al plus one electron is removed, then the energy is required 500 kilojoule per mole energy. 500 kilojoule mole. Okay? Al నుంచి Al plus గా మారడానికి మనం ఎంత ఎనర్జీని యూజ్ చేసాం? 500 kilojoule mole ఎనర్జీని యూజ్ చేసాం. And the second one, this is IE1. Al plus 2. Al plus 2. It is usual to amount of energy is required 1800 kilojoule mole energy. 1800 kilojoule mole energy. Then another Al plus 2, one electron is lost finally, Al plus 3, to give the energy is required 2000 kilojoule mole energy. Directly aluminium, 3 electrons lost to form Al plus 3. It is aluminium, directly remove the 3 electrons. Directly remove the 3 electrons. Some different types of energy is required. One electron is removed, another electron is removed, another electron is removed. అర్థమైందా? డైరెక్ట్ గా 3 ఎలక్ట్రాన్స్ ఒకేసారి అక్కడి నుంచి రిమూవ్ కావు అయనైజేషన్ ఎనర్జీలో. ఒక్కొక్క ఎలక్ట్రాన్ కి ఒక్కొక్క ఎనర్జీని ఇచ్చినప్పుడు మాత్రమే అవి రిమూవ్ అవుతాయి. టోటల్ గా మనం ఫస్ట్ అయనైజేషన్ ఎనర్జీలో ఎంత ఎనర్జీని రిలీజ్ చేసాం? 500 కిలోజౌల్ ఎనర్జీ. సెకండ్ అయనైజేషన్ ఎనర్జీలో 800 కిలోజౌల్ ఎనర్జీ. థర్డ్ అయనైజేషన్ ఎనర్జీలో 2000 కిలోజౌల్ ఎనర్జీ. That is, you can understand IE3 is greater than IE2, greater than IE1. అంతే కదా? IE3 కి ఎనర్జీ ఎంత ఉంది? 2000 కిలోజౌల్. 1800 కిలోజౌల్. 500 కిలోజౌల్. ఎందుకు? Then the unipositive ion is removal of ground state, removal of the ground state of the electron is highly energy is required. High energy is required. ఇప్పుడు మనం suppose center of the nucleus, in outermost electron, this cell is outermost electron, this is another outermost electron. First cell, this is IE1, IE2, IE3. Then IE1 energy is 500 kilojoule energy. IE2 energy 1800 kilojoule energy. IE3 energy 2000 kilojoule mole energy. Then this electron in the nucleus, then the attraction between strongly attraction I3. Then the strongly attraction, then we can not easily remove to electron. Okay? అంతే కదా? న్యూక్లియస్ కి ఎలక్ట్రాన్ దగ్గర ఉంది. Then the nucleus attraction is very high. If the possible electron is removable in highly attraction, no. There is second ionization energy is very small energy, then the nuclear attraction forces between in third ionization energy and second ionization energy is nearly is nearly high. Then first ionization energy, then the nucleus attraction forces is very weak. Then the removal of electron is very easily. అర్థమైందా? ఇక్కడ 500 kilojoule energy ఉంది. Then the nuclear attraction forces of the outermost electron is very long. Then the attraction between very less. That's why electron can easily remove to form unipositive ion. అదే మనకి ఎయిర్ ప్లస్ 2 బై unipositive ion ఏర్పడాలి అంటే we can energy is some amount of energy is required, then IE1 కంటే మనం IE2 ఎనర్జీ కొద్దిగా ఎక్కువ యూజ్ చేయాలి. అర్థమైంది కాన్సెప్ట్? అర్థమైందా? బస్ ionization energy, the minimum amount of energy is required to removal of outermost shell electron in isolated gaseous atom, then it is called ionization energy. Then the units of ionization energy, kilojoule moles. And the minimum amount of energy is required to removal of one electron in gaseous atom, then it is called unipositive ion. Then unipositive ion, to removal of another electron in gaseous atom to form second ionization energy. For examples, next one, factors affecting the ionization energy. Then atomic radius, nuclear charge, screening effect, extent to penetration of orbitals, half-filled or completely filled electrons. Factors affecting ionization energy, atomic radius. There are 5 factors affecting ionization energy: atomic radius, nuclear charge, screening effect, extent to penetration of orbitals, half-filled or completely filled electrons. First one, atomic radius. Then nucleus. The distance between the nucleus and in outermost shell, then it is called atomic radius. Then atomic radius is increases. Atomic radius is increased. Then the ionization energy is decreased. Why? Because then the nuclear attraction forces of the nucleus is very strong. Then nuclear attraction forces between the outermost orbit in an atom is very strong. That's why ionization energy is decreased. That is, ionization energy is inversely proportional to atomic radius. That is, IE is proportional to 1 by air. Second one, nuclear charge. Then the nuclear charge, for example, beryllium atomic number is 4. That is 4 electrons. This is 2 electrons. This is 2 electrons. Then carbon atomic number is 6. This is 2, 6 electrons. Then nuclear charge, 4 electrons is high or 6 electrons is high. 6 electrons is high. Then the nuclear charge is increases. Then the ionization energy is also increased. Due to nuclear attraction forces between the nucleus in outermost electrons is very high. Is very high. అర్థమైందా? న్యూక్లియర్ చార్జ్ ఇక్కడ 4 ఉన్నాయి ఎలక్ట్రాన్స్, ఇక్కడ 6 ఉన్నాయి. దేనికి ఎక్కువగా ఉంటుంది న్యూక్లియర్ చార్జ్ అనేది? 6 ఉండేదానికా 4 ఉండేదానికా? 6 ఉండేదానికి ఎక్కువగా ఉంటుంది. కాబట్టి దిస్ ఇస్ న్యూక్లియర్ చార్జ్ ఇస్ ఇంక్రీజ్. nuclear charge, atomic radius, nuclear charge is increased, then the atomic radius also increase. Atomic radius is atomic radius. Ionization energy is increased. Nuclear charge is increased, ionization energy is also increased. Next, the screening effect. The electrons present in inner orbit, the electrons present in inner orbit, then they screen and reduce the nuclear attraction of nucleus in an atom in inner orbit. అర్థమైందా? The electrons present in inner orbit act as the screen of reduce the nucleus attraction between in outermost electron. This outermost electron. Then it is called screening effect. Then the screening effect is increases. Then ionization energy is also increases. When screening effect is increases, then ionization energy is also increased. Next one, extent to penetration of orbitals. Then the orbitals, there are 4 types of orbitals, that is S, P and V, F orbitals. Then the penetrating order of the orbitals, S is greater than P, P is greater than V, V is greater than F. What is the meaning of S greater than, P greater than, V greater than and F? We will first call the electron S orbital, then next P orbital, next P and F orbitals. Then the penetration of orbitals in the increasing order, then the atomic ionization energy is very high. Then last one, half-filled and completely filled electrons in orbitals. Half-filled electrons, for example, 3d5. Then chromium. (3d10), zinc. This is the half-filled electrons. One electron each orbital, one electron is filled, and everything completely filled electrons. Then the half-filled and completely filled electrons is more stable. Than other completely filled electrons. Half-filled electrons or completely filled electrons is more stable. Then the ionization energy values is very high. Ionization energy values is very high. అర్థమైందా? Half-filled electrons or completely filled electrons is more stable due to ionization energy is very high. Okay na?